let's see what we can do with solving these equations. So I've got one equation here. I've got another one we're going to see in just a little bit. Remember, when it comes to solving an algebraic equation, you have to first identify what kind of equation it is so you know what you need to do. If you have a radical, use the power property to get rid of the radical. If you have a fraction, clear out the fractions. Okay. Now here, I see something that doesn't have a radical, doesn't have fractions, doesn't have absolute values or anything really weird. It does have x to the fourth. And then it goes x squared, a constant, and then a 0. So he looks kind of quadratic, but he's not technically quadratic because of the power of 4. But he is quadratic in nature. And for some of these problems, the way it's set up can lead us straight to the factorization without us having to do weird stuff. Because if I were to split up x to the fourth, I would split it up evenly and say x squared times x squared. And since I have a constant term here, I'm going to try to find factors of 54 that have a difference of 3. And so if you play around with the numbers, you play around with the factor pairs for 54, you're going to find that the winning combination is 6 times 9. 6 times 9 multiplies to give you 54, and 6 and 9 have a difference of 3. So I can fit those in here, so that's going to be a 6, and that's going to be a 9. And then you have to play the game of signs. In order to multiply to get a negative 54, you have to have one positive number, one negative number. But to end up with a positive at the end, the larger number must be positive. A quick check here, you'll see negative 6 times positive 9 is negative 54. And when you check the inside and outside pieces of the FOIL method, you'll see that you'll have like terms that combine to a positive 3x squared. Alright, so we've factored. Now we're going to use that zero factor theorem, which says set each factor equal to 0 and then solve that smaller equation. So x squared minus 6 is equal to 0 and x squared plus 9 equals 0. And at this point, these guys are kind of separate from each other. It doesn't matter what you do here because it's not going to affect the work you do here. So with x squared minus 6, we know the first step here is to move the 6 to the other side. I've got a square. That's the only thing that I see connected to my variable. That's the only variable term that I see. So let's move the 6 to the other side and apply the square root property. Please remember that you're supposed to have a plus or minus here. So x is equal to plus or minus. Now 6 is not a perfect square, nor does it contain a factor that's a perfect square. So it's going to stay just as it is. So right now we have 2 solutions. At the end, we should have a total of 4 solutions. Pay attention to the degree so we know what we're supposed to have at the end. For this other equation, just like I did for the first one, let's move the constant to the other side. So x squared is equal to negative 9. Again, this is a square root property situation. Take the square root of both sides. Don't forget your plus or minus. So x is equal to plus or minus. The square root of 9 is 3. And the negative factor inside is what gives us the I once we simplify that out. Now I want to warn you that I've had students in the past tell me that that means no solution. No, it just means that we have complex solutions. You can plug this back into the original and it's going to be a true statement. Just because it's non-real doesn't mean that it doesn't count as a solution. Alright, so this guy here was quadratic in nature. Let's look at the next one. You'll like the next one better because it is just quadratic. Unfortunately, it has a lot of fractions. But that's okay. Because even though we have a lot of fractions, we can clear out the fractions by identifying the LCD. So if you look at these denominators, you've got 9 and 2, so the LCD there is going to be 18. And we can take that 18 and multiply everything in the equation times that. So I'm going to multiply this first fraction times 18, this times 18, this guy times 18, and even the right side of the equation. Everything gets multiplied times 18. Now when it comes to simplifying, you might do better to write this as 18 over 1. You don't have to, but again, show good work and make sure that the work is going to help you understand what's going on. So what happens now is that the 9 goes into 18 2 times, and so we get 2x squared. And here, 2 goes into 18 9 times, so 9 times 1x is 9x. And then 2 goes into 18 9 times again. And 0 times 18 is just 0. All right, so we got rid of the fractions, so that was the first problem. And now we have something that's quadratic. Okay. So let's see, how are we going to do this? Square root property doesn't work because I have 2 instances of x. The next thing I would try would be zero factor theorem. So let's see if this guy factors. So off to the side, now I'm not saying we have to factor, I'm saying let's see if we can factor. So off to the side, if I do the AC method, so a times c is 2 times 9, which is 18, and I want to see if I can we find factors of 18 that we'll be able to add to get the middle coefficient. And you know that if you factor this the right way, as 3 times 6, you've got a winning combination. So the AC method says that once you get that winning combination, you are now going to rewrite this middle term. So instead of saying plus 9x, use the 3 and the 6 to rewrite this as plus 3x plus 6x, and then you've got the plus 9 that was the constant, just bring it down. You might think that I've changed the problem, but look at this. Plus 3x plus 6x is still plus 9x, so I haven't changed anything. In fact, what I've done is I've been able to rewrite the problem to have 4 terms, which means I can now factor by grouping. So in the first group, I have a common factor of x. Factor that out, and I'm left with 2x plus 3. And then in my second group, my common factor is 3, so that's a plus 3, and factor out the 3, and I have 2x plus 3. And you'll see here that these guys are exactly the same. That's the whole purpose of doing factoring by grouping. So we have 2x plus 3 times x plus 3, and take the time to FOIL everything back out to check that it does give you this equation. And then from here, you're going to use that zero factor theorem. So 2x plus 3 is equal to 0, or x plus 3 is equal to 0. And it doesn't really take much time at all from here to finish solving this. So x is equal to subtract 3 divided by 2, so negative 3 halves. Or over here, move 3 to the other side by subtracting it, and we get x is equal to negative 3. And just like that, you're done. So the key thing here was to clear out the fractions to make the problem a lot easier to work. And then you could just go about factoring, solving it, and being done.